Okay, friends, myself Anand Reddy, retired from Geological Survey of India as a director. Today, I am going to explain the advantage of this ABEM unit. Actually, so this purpose of this ABEM unit is to measure different properties of the earth, because the main purpose is to measure the self potential of the ground. Second is the resistivity of the ground, and third is the induced polarization effect of the ground. So why we will do this exercise actually? Because we are searching for whether first for groundwater or minerals. So if we want to do surveys for mineral, so we need what is the exact nature of the geological environment actually. What type of rock the minerals are present actually, what is the nature of the mineral, whether it is disseminated or massive, or what is the type of mineral, what is resistivity. Simply that is V by I into K. V is voltage by current into constant. So here actually why we will do the resistivity, because the resistivity of a hard rock is completely different from a resistivity of the soft rock. Now it is we are working for in Telangana area. So what type of rock we can expect here? Generally very hard rock. So can you expect any rock or any water in this hard rock? Any water within this hard rock? You cannot. So where we want, but we are searching for water. So what exactly the principle behind that one? So where to locate groundwater in the hard rock terrain? Come on, because you three are there now. So what type? Yes, fractures. So we have first our purpose is to identify the fracture system within the hard rock. So for that, resistivity is the best method to differentiate the very hard rock from the fractured rock, because fractures may get either horizontal or in vertical or inclined in any direction. So our purpose is to identify the fracture system within the hard rock. So it may be in a deeper, it may be in a shallow, it may be in an incline, any direction it may be there. So profiling is the best technique. Profiling is the best technique to identify the vertical variations. And one more method is there, resistivity sounding. In that resistivity sounding, what we will do, that is the best for this layered complexes in sedimentary rock area, not in the hard rock area. So sedimentary rocks, if it is there, sandstone, shale, limestone, like that, there it is there, we will know the horizontal variations at a depth, up to a depth. So in that we can measure the thickness of the individual formations and resistivity of the individual formations, and any fracture zone within this one we can able to maintain. So sounding is best for the sedimentary terrain, and profiling is the best for the hard rock terrain. That is the main purpose. Again, in the profiling, there is a number of varieties. Again, one is Werner, everybody knows. Second is the Schlumberger. Again, in the Schlumberger, in the Werner array, you will keep all the same distances: current to potential, potential to potential, and potential to current. Again, A is same for entire range. But in the Schlumberger, we have to maintain the distance of minimum more than five times from potential electrodes to current electrodes, because we will keep the current electrodes in a far away and keep the potential electrodes in the center, and we will move. That is Schlumberger. Again, in the Schlumberger array, again another 5-6 types of arrays are there. One is simply everybody knows Schlumberger. Second is 2 electrode array, 3 electrode array, dipole array, pole to pole array, and gradient array. There are 5 to 6 varieties are there. Because depend upon your objective or purpose, we will choose the methodology. So here, if you want to go for a groundwater in a hard rock terrain, best for the profiling technique with Schlumberger array. Or in that again, we will go for the gradient array. That is the best technique to identify the vertical variations within the hard rock terrain. If you go for a sedimentary terrain, best suitable method is the resistivity sounding to locate the potential aquifers within the sedimentary formations at a depth. That is the second one. So another method is there, SP. SP only you can measure to know the direction of the flow. That is the main advantage in this one, that we can able to identify from the SP. And third is the now we are doing this multi-electrode resistivity profiling. Ordinary profiling and this multi-electrode profiling is a lot of difference there. Here there is at a time you can fix the current electrodes or potential electrodes in a stretch 30 to 60, and we will send the, it will take that one everything alternately, one by one it will send the current between the current electrodes and measure the potential difference between the potential electrodes simultaneously along the profile, entire profile. The advantage is in a single stretch we can know the vertical variation, vertical resistivity of the particular profile up to a particular depth. Maximum will get up to 80 meters in this multi-electrode system here.
And how much?
80 meters. 80 meters. We will know the what is the any fracturing system is there, any low resistive zone is there, any hot rock is there, any mineralization is there. Everything we can able to identify.
You will also see.
Please. Please. Okay. Okay. Kucham.
Sit down somewhere.
By
A lot of time is there. Comfortably.
So now we are doing this.
Bring white paper and pen.
Now we are doing this one.
30, 35.
Mainly mineral exploration only I am doing this. So now we are using this instrument for locating minerals actually. So you will get different types of minerals again, metallic, non-metallic types of there. So this is IP. IP is what is the exactly IP meaning? So if you want to, if you send some current to a non-metallic mineral, what will happen? Lot of resistance will be there. Suppose your quartz vein is there, you send a current, it will not pass through that one. Simply it will reflect. So resistivity is high for a quartz or pegmatite or this type of things. Suppose if you send a current to a metallic body, suppose a major mineral is there, base metal is there, copper is there. So if you send it, it will absorb it because lot of connectivity is there, it will pass through the current. But if you cut the current, what will happen? It will not suddenly decay, it will slowly decay the current. So the difference, the time taking for cutting off the current from edge to edge, that is called as decay time. So if it is decaying is more, then the sulfide content is more in the metallic body. Only sulfides will give the IP effect, not other. It will only useful for the sulfides to identify. Sulfides found in base metals or gold and other, so many metals are there, sulfides. So main purpose is to identify the gold mineralization or platinum mineralization or base metal copper ledging mineralization. All these things in all these types of minerals, you can use this IP system is the best. Okay. So here also I told you the main principle, decaying. So what he is doing now, we are sending the current and immediately it will cut the power and the decay time will measure. Depends upon the decay time. It will, if you take a larger time, then the content of the mineral body is more. If it is fastly decaying, then it is a non-metallic body. So depending upon the nature of the rock type or geological environment, so we will able to identify, differentiate, and we can correlate also with the data with the other data actually. That is the main purpose of this IP method. Okay. And if you have any other doubts, please. With the same unit, we have collected the data, resistivity data in Shankarpalli area. It is almost some 30 kilometers from this area. Actually, this is the almost, I think it is a east-west profile. East-west profile. See depth, we got the information. If you see this one, actually, these are the electrode spacings and the depth, because distance actually, this is the distance, this is the depth actually, vertical. Here the different colors, the blue is the lowest color and the red is the highest resistivity, this is low resistivity. So from this we can easy to identify this is an aquifer, small aquifer here. Fracturing system.
Low resistivity and what is high resistivity?
Okay. Why I already told now, why resistivity, if major fracture system or any element or so other structural disturbance is there, you will get the resistivity loss. So this may be
resistivity absorbed by the material.
Yeah. So if you see this one here in the western part, this shallow resistivity low zone is there. Here it in the central, in the eastern part, a deeper portion is extending beyond 70 meters, beyond 200 feet. So it is going to be a deeper aquifer. We will get the water in the shallow also, but the same aquifer is continuing up to depth. If you go to the eastern part, it will not give much water actually, very shallow in the blue line in the eastern part. So here is the best aquifer is this one, low zone. I will show one more is there.
Sign of what is
Not water, that is a major fracture system.
when you send from there to there, maybe half a kilometer. So we are sending some current, right? And we'll receive something. So if it is a hard rock, hard surface, we cannot say it is a rock. So if it is where the permeability is less, so absorption is less, reflectance is more. So system will not say which one is a water, which one is a rock. So that reflecting. So again, based on other interpretation techniques, we have to correlate whether water is there or not. But if it is a rock, resistance comes first. It is a if we say it is a impermeable layer,
This red one
then
is hard.
reflectance or resistance.
What one?
is less.
This red one is
This red one is a hard rock, complete massive. This is a massive granite. Here it is one advantage in this profile actually. Okay, this is another profile actually. This is in north-south direction actually. You see here, this is almost parallel to the major lineament actually. You see, this is a lineament tending in almost north-south direction. This is shallow aquifer. All along the aquifer, wherever you put a drill, you will get a lot of water. It is how it is to say. It is almost very well corroborating with the lineament because that is a low resistive zone. Lineament means a highly fractured zone. So it is reflecting as a shallow resistive layer up to almost 30 to 40 meters. It is there. So it is corroborating very well with this fracturing system with the resistivity data. So we are collecting from this instrument only. All along the profile, wherever you can put any place, you will get a lot of water in this one. Because it is parallel to the lineament. That is the advantage and parallel to the lineament, north south direction. All along the lineament, very low resistive zone. A classic example. Classic example.
Recharge zone also.
Recharge zone is.
How many length?
This is almost 300 meters, no? Okay, good. Second profile, Shankarpalli.
A lot of changes.
Yes. Exactly. చూడొచ్చులేండి ఇక్కడ చూడొచ్చు కావాలంటే distance from here 240 here and it is 168 and almost 240 ఉంటుంది almost 500 meters profile.
And the depth is 70.
Is very maximum depth is 70, but in you see here very hard rock is there at depth, so there is no deeper aquifer here, only shallow aquifer. So this is one classic example.
Up to 70.
Maximum, maximum
Depends on
70.
horizontal width. If you increase the
If you increase the width, it will go further slightly.
if you increase on the surface, it will go more into the deeper.
So that is the advantage in gradient array. We can put 400-500 meters distance, then we can able to send the power up to 150 or 1500 meters, 1500 feet. So we'll get the deeper aquifer also in this gradient array.